Okay, so we continue to finish the production theory section. Okay, so we studied about the definition of MRTS and the properties of the MRTS with the relation to the isoquant curve. Okay, so there are only two things you should remember: the definition of isoquant and the definition of MRTS. But still, no need to memorize because you're gonna have another open book test for 90% for sure. Our college is now investigating the possibility of in-person final exam, but we are highly negative on the possibility that every and each class will have in-person face-to-face final exam because first of all, the room availability problem. For instance, our class is 100 students are taking the microeconomic theory course for the trade department, and there is no room to take the final exam for 100 students inside the college building because we need to keep distance between the students enough to follow the government policy, but there is no room to have 100 students. So we need to make a reservation for 정심화 hall. That's the only hall that can consume the 100 students. But it is really hard, extremely hard to compete with all the other departments in the university for that final time. Okay, the same problem for most of departments and most of courses, which is rather than 50 or 60 students per class. So the college is still investigating and they are trying their best to find out the suitable rooms and times for the in-person final exam. But if we are really lucky that we can get the room, that we can take the in-person final exam. But I don't think we can do that, in my point of view, at this point. Okay, just my opinion. Anyway, we can continue discussing about the MRTS and the Isoquant. So this graph is really important for your understanding about the properties of MRTS and the economic meaning of MRTS with the law of diminishing returns. Okay, so the point is that the quantity of output is fixed at the 10 in this graph, but the combination between the two inputs, the capital and the labors, are varying each other. If you increase one input, then the other input will be decreased to maintain the same level of output, which is the definition of MRTS. And the economic meaning of MRTS is that if you keep increasing one side of input, then the marginal replacement of the other good, in terms of that good, that input, in this case the labor, will be decreasing because your marginal output or marginal return will be diminishing. Okay, so another practice problem: perfect substitute and the MRTS. Does the marginal rate of technical substitution vary along the isoquant for the firm that produced the potato salad using the 강원도 and the 충남도 potatoes? What is the MRTS at each point along the isoquant? So this problem is the example. So the information is not fully provided in the question, but this question assumes that the potato salad from the 강원도 and the 충남도 are the perfect substitute each other. So as we saw in the graph version of the perfect substitution or perfectly substitute goods, perfect substitute input, there is only one slope because the isoquant curve of those two inputs they are perfectly substitute is the linear. So it is straight line, downward straight line. So the potato salad isoquant are straight line because those two types of potatoes are perfectly substitute each other. So the slope of that straight line is the same at every point. So there is only one MRTS, which means that your MRTS of that isoquant curve is a constant, only one number. So even if we further assume that the Gangwon potato and the Chungnam potato, the quality of those two potatoes are identical each other, then the slope should be the -1, because the one potato from Gangwon should be replaced by one potato for Chungnam, right? Chungnam potato, or 1 kilogram, or 1 kilogram of Gangwon potato should be replaced by the same amount of kilograms of the Chungnam Provence potatoes, because their qualities are the same and they are perfectly substitute each other. So the slope should be -1. So you can apply some example to the concept of MRTS, then you can answer with some specific number, which will be the slope of MRTS with this type of question, if you have a similar question in your final exam. So I will find out some practice problems that can make you better prepared for the real exam, not multiple choice at this point. Okay, so a little bit complicated equation, but the economic meaning or economic insight is the same. So don't panic, you can just understand the step by step. Okay, another emergency text message from the government, the 재난 문자. Have you ever visited Itaewon gay club? Do you have any experience in doing that? Because gay club does not close to the hetero person. I mean, if you are guy, but if you love woman, then you can still come in the gay club. There is no block, but so you can see the site and what happening in the club. Anyway, so I was just curious because Itaewon is pretty famous for inviting the LGBT guys from anywhere in the South Korea. So you can easily meet that LGBT guys on the street of Itaewon. And the clubs, now they became a headache for the nation, are pretty much famous for doing some extreme things. So this coronavirus situation, pandemic situation, revealed some extreme cases of South Korea. The first one was the Shincheonji, and the second one was the gay culture. So as a social scientist, it is kind of homework for me to have a insight about the situation, what the coronavirus revealed to our society, and what the social problem that should be solved collectively. But anyway, if you have any family or friends who tested positive on the coronavirus, then you should be with them, not physically with them, but emotionally with them, and comfort their minds. Pretty sure, even if they are gay or lesbian, whatever, you should be really close to them if you are family or friends with them. Okay. But anyway, let us try to understand this equation. Okay, so we still assume that the delta Q equals to 0. What does that mean? We can have the fixed level of output. So output does not change. Maybe you can assume the output is 10 or output is 15 and it does not change. So the only changed variables are the two inputs, the labor and the capital. So delta L and the delta K will not be a zero anymore. And we can introduce one more concept, marginal product things. And I assume that many of you guys will be already familiar with that concept. The marginal product of labor means that the additional amount of output contributed by the extra increase of one input. So marginal product of labor means that marginal increase in the quantity of output because of the extra unit of labor. Okay, so if you increase the labor, for instance, which means that the delta L should be a positive, okay, then there will be the positive MPL, marginal product of labor, okay. But we assume that the delta Q should be zero because we want to stay on the same isoquant curve. Then the delta K should be negative, which means there will be some negative MRTS, and we know that since the MRTS is already, since the isoquant curve is always downward graph, so the slope of isoquant should be negative, which means that there is always negative MRTS, right? Correct? So we can decrease the delta K to keep our quantity unchanged. How many? That's the question of the equation number 9. Okay. So the total amount of output with the extra unit of labor is the first term of the equation number 9. The marginal amount of quantity output for the extra unit of labor, and the delta L is a change of amount of labor input. So that's the total amount of output contributed by a change of labor. So we assume that that is positive number. Then there will be a negative number, which will be exactly the same with the first parenthesis. The second parenthesis means the total amount of output that is decreased by the decreased amount of input K, right? Because MPK, or the marginal product of capital, means the marginal increase in quantity of output because of the extra unit of capital. So if you increase one more capital, then there will be some increase in the total output, that is the MPK. But you increased amount of capital by delta K. So the delta K times MPK means that the total output because of the delta K. And the first parenthesis, MPL times delta L, should be cancelled by MPK times delta K, right? So the first parenthesis, MPL times delta L, the absolute value of that parenthesis should be exactly the same with the absolute value of MPK times delta K, right? Because we assume that the delta Q should be 0. So quantity of output does not change over time at this point in equation number 9. So equation number 10 is the result of management of, or the simplifying equation number 9. So simple calculus. Not calculus anymore, so it's a simple algebra thing. So you can do by yourself, then you can get the relationship in the equation number 10. So the MPL over MPK should be the same with the negative times delta K over delta L, which is the definition of MRTS. So MRTS should be equals to the ratio of those two marginal product of the two inputs times negative. Okay, that's the equation number 10 is pretty much I think the most important equation in the production sector, because with that equation you can find out the most efficient point of production for a single producer. So this page is the practice. The Cobb-Douglass production function is the specific form of the production function, like equation number 11. So your level of output will be affected by, on the right hand side, A means the total factor productivity. It is the level of technology. So we usually assume that A is constant term, but sometimes A can be a variable, but at this point we can just assume that A is a constant. And some level of L to alpha. So it is not linear function. It is not linear function anymore in the Cobb-Douglass production function mechanism. So your output will be affected by L to the alpha times K to the beta. And alpha and beta are the positive number, which is larger than 0, but smaller than 1. So the alpha and beta are the parameter values, which are presumably determined by statistical estimation. So usually alpha and beta are referred to be the ratio, relative ratio of the labor income to the capital income. Okay, so usually alpha plus beta equals to 1 in many economics research papers. But you can simply assume that the alpha and beta are the positive number, which is smaller than 1. Okay. So with this specific form of Cobb-Douglass function, then you can have some simple algebra and a simple calculus to find out the MRTS in terms of alpha, beta, K, and L. Okay. So how about that? The MRTS will be equals to delta K over delta L. But from the equation number 10, it also equals to negative MPL over MPK with this equation number 10, right? So MPL means that the result of taking derivative of your production function with respect to L. And MPK is the result of your calculus to take derivative your Cobb-Douglass production function, equation 11, with respect to K. So you can take derivatives with L and K, then you can find out the real value of MPL and MPK, which will be equals to negative alpha Q. And you can also fix the Q equals to Q bar, because this one, the first line of this page, the delta Q is not changing. So simply to find out the MRTS, you can assume that Q in equation 11 should be just Q bar, unchanged it, constant value. Then you can take the calculus, okay? Then the Q bar will be cancelled out each other in the numerator part and the denominator part. So the Q bar will be cancelled out each other on the both sides. So the remaining part will be the consist of the alpha, beta, K, and L. So you can find out the real value of MRTS. You can do that by yourself, definitely. This is not hard calculus. I think it is much lower than your high school level of calculus. And if you are Chungnam National University student, then you can definitely do that. Okay, so the last one to study about is the returns to scale. So the return to scale is pretty much important property of production function for a single producer, because at some point you need to determine whether you're gonna expand your business or keep maintaining the same size of business. Okay, if your chicken restaurant is in boom situation because everyone likes your chicken, then you're considering about hiring more labor or buying more machine to cook chicken, not kitchen. Kitchen, chicken. Where it's complicated. We're complicated, confused. I hate English. Okay, so there are 3 types of scaling of your business with a term of the production function. So this is the situation of the long run, because L and K are both variables, so we can change the level of L and K. So we are living in the long run situation. So the CRS, or the constant returns to scale, means that if you increased L and K by 2 times at this point, then the output level will be exactly the 2 times more than the original level. And this 2 is the specific example, so you can have the different number, like 3 or 1/2 or something. But anyway, the important and bottom line of the CRS means that if you increase the L and K with the same ratio, then each amount of output will be the same with exact the same ratio of increase of your total output. Okay, so you can compare then the left hand side and the right hand side. Increasing returns to scale. Many students may be confused with the increasing direction and decreasing direction. So be careful about this one. The increasing returns to scale is that if you increase your inputs by the same ratio, then the output of that result will be larger than the monopolistic increase of that ratio of your output, the 2 times Q. Okay, so which means the economic meaning of that is that if you increase your inputs by specific number or specific times, then some production function mechanism is really efficient. So the output will be larger than the monopolistic increase of your expected returns, Q. Okay. If we have the different direction, then you can call it the decreasing returns to scale. Okay. So even if you increase your L and K by 2 times, the output of that one should be smaller than the 2 times Q, your expected returns. And there will be some inefficiency in your production function mechanism in this case. So another Cobb-Douglass function practice problems. Under what conditions does the Cobb-Douglass production function exhibit decreasing, constant, or increasing returns to scale? So this is very good example for your final exam. I like this type of question because you can practice by yourself and you can just scribbling on the white paper with your pen and you can calculate by yourself. Then you can find some specific condition to satisfy some stated version of the result, decreasing, constant, or increasing returns to scale. You can do that by yourself, I think. And the hint of that is that you can have specific form of Cobb-Douglass function. Then you can do the same thing. Put 2 times n or 2 times k inside the L and k. Then compare with the q or 2 times q or something. Okay, then you can find some specific condition. If you cannot do that, you can post on the question and answer board. Then you can just solve together. So this is the real data to show that some industry in some countries show decreasing returns to scale or constant returns to scale or IRS or increasing returns to scale. So how about the United States tobacco product? The labor alpha and the capital beta, those two scaling things are smaller than 1. So I think this table is the answer to our practice problem. The answer is that if alpha and beta is smaller than 1, then it will be the decreasing returns to scale. If alpha plus beta equals to 1, then it will be the CRS. And if the alpha and beta, alpha plus beta larger than 1, then it will be increasing returns to scale. So the answer is like that to your practice problem, but I think I urge you to solve by yourself with your hands. It will be fair for you. But anyway, interesting thing is that the Japanese beer industry, the labor income share is 60% and the capital income share is 40% in the Japanese beer industry. So the alpha and beta the summation of those two ratios are definitely just exactly equals to 1. So Japan's beer industry is the good example for the constant returns to scale. Bangladesh fabricated metal industry. Wow. You can see that the labor income share is almost 1, and the capital income share is less than the 30%. So it is really labor intensive industry. So if we are interested in international trade, the textile industry in Bangladesh is really popular over the world, and textile industry is really heavy labor intensive industry. So this is good data proof for that theory. How about Chinese high technology things? Labor income share is less than 30%, and capital income share is 66%. So the summation of those two things is a little bit smaller than 1. So we can say that it is slightly decreasing returns to scale. But IT industry, like the Chinese high technology industry, is capital intensive industry. So the capital income share is pretty much larger than the labor income share. Pretty interesting. So this is graphical representation of the return scale. So the beer industry, in this case, if you increase the labor and the capital by 2 times, from 100 to 200, your output is 200. It is exactly equals to the 2 times Q, right? So we can say that this beer industry is the constant returns to scale. How about this one? The tobacco industry. If you increase your labor and the capital by 2 times, from 100 to 200, but the quantity of output is 142, it is strictly less than the 200, or the 2 times Q. So it is the decreasing returns to scale. This one should be increasing returns to scale, because you can produce more by 2 times of labor and 2 times capital, which is rather than the 2 times output, 2 times 100, or 2 times Q. So this is the summation of everything. From point A to point B, you multiply 2 to your labor and capital, but the output is 3, or the 3 times of your original output, 3 times 1. So from A to B, it is IRS, but from point B and C, it is CRS, and point C and B, it is DRS. Okay, so I think it's pretty much clear to everyone about the returns to scale. So last thing we need to discuss about is the technology thing. Changing technology is totally another issue in economics, so we don't have much time to discuss about it. But how about to go back to the Cobb-Douglass functional form here in equation 11? We have ignored the amount of A in the equation number 11, but I told you the A is defined by the total factor productivity, which represents for the technological changes. So changes in A can definitely affect the amount of Q, or the output. So many economists are really interested in the level of A or the evolution of A. So different firms will have the different technology or different productivity. Okay, and these technological changes can be affected by innovations or the other factors like management skills or government policy things or R&D things, many things, which cannot be explained by a model we have studied in this chapter. So we can just briefly discuss about it with many abstractions. So technological progress or technological evolution, which will be heavily affected by some stacked or accumulated knowledge of the human beings in the history. So the knowledge situation or the knowledge issue is another big topic in economics. And if we have enough time, luckily, then we're going to talk about that knowledge spillover things, because it is really important issue in the international trade theory part. So if we study about it, then it could be pretty good preparation for you guys before going to the international trade theory course in your third year. All right. So this is the end of production theory, and we're gonna do some application part for the production theory, which will be pretty much more complicated. But anyway, I'm happy if you have the fundamental knowledge about the production part. So we'll see you next time.